All right, this is the review part 1 for your SLO. So the first thing we're going to review is Newton's second law. So everyone knows that Newton's second law is F net is equal to m times a. We need to break it apart and figure out what each of the pieces mean, though. And then we're going to practice a couple problems. Remember, we are preparing for our SLO, which is like your final exam and a test grade in the class. So make sure that you're paying attention. Do your work this week so you don't have to take the final exam at the end of the semester. Okay, so we're going to start. We have Newton's second law. F net is equal to m times a. What is the net force? That's our first question. What is a net force? Anyone remember? So when you combine all the forces, you get the net. So everyone should have this right here, which is the net force worksheet, which at the top it says the force that results from all combined forces is called the net. Calculate the net force in the box on the following problems. And then be sure to indicate or include the direction of the net force left or right. So in box 1, what forces do I have acting on box 1? 4 newtons to the left. Is there anything going to the right? No. So if I were doing F net, it would equal right now 4 to the left, which the left is positive or negative? Negative, so it would be negative 4 newtons, right? And then remember at the end, we change negative into direction and get rid of the negative. So negative was left, so this is 4 newtons to the left. Very simple stuff, right? Let's do another one, number 2. So we have 7 newtons to the left, 2 newtons to the right. So again, all we have to do is add up our forces. We have 7 newtons to the left. So is left negative or positive? Negative. So I've got negative 7 newtons. And then I've got 2 newtons to the right. Is the right negative or positive? Positive. So 7 newtons to the left plus 2 newtons to the right. Negative 7 plus 2 is how many? 5? Negative 5. So we have negative 5 newtons. What does the negative represent? The direction, which is left. So the net force acting on this box is going to be 5 newtons to the left. Anyone confused so far? Pretty easy stuff. It's almost like I taught you something this year, right? All right. So let's look at one that is going to confuse people a little bit, right? Not because it's hard, it just is drawn differently, so it's confusing. Okay, so number 4, we're going to do the same thing. F net equals, what is this one right here? 6 newtons to the right. Even though it's on the left side of the box, it's still going to the right. So I have 6 newtons. And then I've got 3 newtons. Where's it going? So that's going to be plus 3 newtons. 6 newtons plus 3 newtons is how many newtons? 9 newtons. It's positive or negative? Positive, and positive means to the right. Y'all so smart. Okay. Easy stuff so far? Okay. All right, now we'll get to the most confusing net force problem that we have on this sheet. Number 10. Okay. So remember, F net is not just the sum of 2 forces or just the sum of 1 force, it's the sum of all the forces. So, number 10, we have F net equals, what's our first force? 7 newtons, left or right? Left. Is left positive or negative? Negative. So I got negative 7 newtons. What's my next force? 4 newtons, right or left? So plus 4 newtons. And then I've got another force on there. What is it? 4 newtons to the right again, right? So plus another 4. So negative 7 plus 4 plus 4 is how many? 1 newton. So F net equals positive 1 newton. Positive is to the all right, that's the front side of the page. I'm sure that y'all can finish the rest of these with no problem, right? Okay. Let's go over to this word problem area. Okay. So we have a boy pulling a wagon with a force of 6 newtons to the east. As another boy pushes with a force of 4 newtons to the east. What is the net force? So if I'm going to do this problem, what do I need to do? Draw a picture. So part of the given would be to draw a picture. So just like we had up top, we're going to do the same thing. So I have north, south, east, west. For those of you who don't remember how this goes, north, south, east, west. Okay? So I have 6 newtons to the east, so I need to draw that on my diagram, right? Where am I going to draw it? On the left? To the right? Boy's pulling the wagon this way, 6 newtons. Okay? Another boy pushes the wagon, so he's going to push on this side, right? So one's pulling, one's pushing. Okay, and this one's 4 newtons. Now it's just like the problems that we had up top. Super simple to solve, right? Yes. So we just have 4 newtons. To the right, is right positive or negative? Positive. We have 6 newtons. And right is positive or negative? Positive. So 4 plus 6 makes 10 newtons, and it's positive, so it's to the right. Okay, easy enough? Yeah. All right, let's put that down. Okay, so what is a balanced force? When the forces are the same. That's pretty close. So a balanced force would be when I have, for instance, 5 newtons to the right, and I have 5 newtons to the left. These are said to balance. They cancel each other out. Okay, so that's a balanced force, as opposed to an unbalanced force. So what would an unbalanced force look like? Okay, so one side's 8, and the other side would be 2. So a balanced force, the net force is how much? 0. For an unbalanced force, the net force is how much? Any number but 0. So that's when we end up having something happen. Do y'all know what happens when we have an unbalanced force? Something is going to be moving. How is it going to be moving? This is the special part. So let's look back. We started over here. F net equals M times A. That's right. So if I have a net force, meaning it's unbalanced, I'm going to then have an acceleration. So net force is the sum of the forces. And we said if the sum of the forces is unbalanced, meaning not 0, then we're going to have an acceleration. So can you tell me what is an acceleration? Speeding up. Well, what's speed? It's how fast you're going, right? So if you're speeding up, you're accelerating. So what's changing? Your velocity is changing. So an acceleration is nothing but a change of velocity. It's not on your paper. So, a change of velocity. This is why it's part of the notes that we're taking for the SLO. You have to remember this stuff, right? Now, this is basic from first chapter or second chapter of the whole book. So, when we talk about a change of velocity, that means that our speed is changing. It could be increasing, it could be decreasing, or it could be changing. Anyone remember the last piece? So velocity means that you're changing your speed. You could be increasing it, you could be decreasing it, or you could be changing direction. There we go. That's what I was looking for. So change of velocity, it could increase your speed. You could decrease your speed, or you could change your direction. Because velocity is not a scalar, it's a vector. Good. Okay, remember velocity, vector, they both start with V. Vector is anything that has a magnitude, meaning the number that describes it, as well as the direction where that magnitude is going. So speed would be saying I'm going 70 miles per hour. Velocity would be saying I'm going 70 miles per hour to the north. Or I'm going 70 miles an hour to the right. Or I'm going 70 miles an hour down the field, which is really fast for a field.
That's so good.
Yeah. Okay. So, if I have a situation like this, I have a 50 kilogram box. Okay, so start with a 50 kilogram box. And I apply a force of 20 newtons to the right. While someone else applies a force of 10 newtons to the left. My question becomes, what is the acceleration of the box? And what is the net force of the box? So this is my given. My unknown is net force and acceleration. Okay? Okay, well, we're really good at doing net force already, right? F net, you just add up all the forces. And then that F net is going to equal to your mass times your acceleration. Okay? So let's add up our forces. F net is, we got 10 to the left, so left is positive or negative? Negative, so we got minus 10. And then we got 20 newtons, and that's to the right. Is that positive or negative? Positives, good, so plus 20. Equals how many total? That's right, it's going to be 10, but what kind of 10? Positive 10, okay, good. So I got positive 10. Unit for force is newtons. And since it's positive, it's going to the right. Very good. Now we just have to go to the next step. F net equals m times a. So I've got positive 10 newtons is my F net. What was my mass up here? 50 kilograms. Times a, which is? Oh, we don't know it, right? But it is the acceleration, so just A. We write it in. Okay, what's that 50 doing to the A? It's multiplying. What's the opposite of multiplication? Division, so we divide by 50. 10 divided by 50. Anyone know what that is off the top of their head? 0.2. That's good. 1/5. Okay, so 0.2 is equal to our acceleration. Okay? Now, is this a positive or a negative? Positive. Positive means to the right. So I got 0.2. I've got right. Now I just need, what is the unit for acceleration? Meters per second squared. Okay. So the acceleration is 0.2 meters per second squared to the right. What does that mean? What's our box going to be doing? If it started and it wasn't moving, what's it doing now? It's moving to the right. But how is it moving? Slow? Okay. Well, after a second, how fast is it moving? So, it changes a meter per second every second. That's what the second squared part is. So, at 0 seconds, it's moving 0. So, we're looking at velocity. So, at 0 seconds, it's 0 meters per second. After 1 second, how fast is it moving? It's moving at 0.2 meters per second. After 2 seconds, how fast is it moving? 0.4 meters per second. After 3 seconds, how fast is it moving? 0.6. So all it's doing is every second it's changing by how much? 0.2. That's what an acceleration is. It's just a change in velocity every second. So for instance, gravity. When you're falling, what is gravity?
The stuff that's pulling you down.
Gravity pulls you down, but how does it pull you down? Does it just pull you down at a constant speed? It's like if I jumped off of a 3-story building, would I be going the same speed when I hit the ground as if I jumped off of a curb? No.
Super fast.
So gravity isn't just a velocity that pulls you, it's an, not a force, acceleration. So it's speeding me up. How fast is gravity? So gravity is 9.8 meters per second squared. So after 1 second, how fast am I going towards the ground if I started at rest? 9.8 meters per second. After 2 seconds, how fast am I going? I know 9.8 times 2 is hard. What's 2 times 9? Yeah, 2 times 9 is 18, and 2 times 8 is 16, but there's a decimal. Add the two numbers together, you get 19.6. Now for the really hard one. After 3 seconds, how fast are you going? How fast? Yeah, 29.4 meters per second. Okay, so that's what acceleration is. Acceleration is just a change in your velocity every second. So that's why it has the units of meters per second squared. It's meters per second every second. Okay? All right, so that is our lesson for acceleration, net force, and what acceleration and force actually are. So you just have to finish up your worksheet now, and everything will be good.